Hi everyone, I hope you're all well. Good to see you all again. Please say hello in the comments. It'd be great to introduce you. So we've got a lot to do today. The last session was quite straightforward. This one is we've got a lot more to get through. So let's see if we can crack on with it. I hope you are all good. Networks and topologies. That's the grand plan for today. But networks and topologies. That's the grand plan for today. And as ever, don't leave on your volume when you're doing it, or you get a horrible shock. There we go. So quiz time, rewind. Let's see how you cope with this one. Do say hello in the comments. It would be great to see you. Right, now I'm hoping after this, the 100th attempt, that you're going to get this one absolutely spot on. Let's see how it goes. We're talking about registers. This has been the question that we have tried to get through repeatedly. Which is the register that stores the address where the data will be read? Jumbo Lizard, hello. Right, let's say hello to you guys. Who've we got here? We've got Aditya. Hi, Aditya. We've got Jumbo Lizard. Hello, Jumbo Lizard. We've got Sergen. Hi, Sergen. How are you? Bogdan, good to see you again. Hash Brown Gaming, how are you? Sharjeev, thanks for coming. Oh, and Bogdan's come in with an answer. Memory address register. The first with an answer. We've got Pixelator. How you doing? Good to see you. Man like Paul, thanks for coming. We've got Aditya with the MAR. Oh, Whackman, my guy. We've got Aditya with the MAR. Hi. And we've got Hashbound. MAR. We've got Emad. How are you, dear boy? So you're all here. Brilliant. Is it the MAR? But is it? That's the question. Is it the MAR? What do you reckon? Let's have a look. It's the MAR. Woo! Let's play some applause because I know it'll really cheer you up. You have a free ding. You have an air horn. We can have a triangle. We can even have a glockenspiel. That's how happy I am that finally you've got this sorted out. So only 3 more to do. It's difficult, isn't it, remembering all of that? But that's brilliant. That is the MAR. So that is outstanding. Who else have we got here? We have got... So hang on. We had... Hash Brown Gaming got it right. Aditya got it right. Emad got it right. We know. Sergen got it right. Man Like Paul got it right. Brilliant name. Swiftblade, hello. And Swiftblade wasn't quite sure, but hey, listen, doesn't matter. MAR, that is the answer we were all after there. So that is outstanding. Only a few more to do in that case. All right, what about this one? Bit depth. Yeah, why wasn't I in school? I had some kind of horrible lurgy. I thought I had COVID, did all the tests, wasn't COVID. I just had something else. I felt shocking. I felt bad for abandoning you, but I had to just lie on my sofa and groan for a couple of days, sadly. But that's the way it goes. So what is meant by bit depth? So this was week before last. We looked at sound, didn't we? So bit depth. What is meant by bit depth? So we have got, let's have a look. We've got Aditya, who's come in with C. We've got Swiftblade 46, who has come in with C. Sergen, who's come in with C. Jumbo Lizard, who's also a C. And Emad, who's a C. And Hash Brown Gaming is a C. And Flynn, hi, thanks for coming, who is also a C. Good to see you, Flynn. There we go. All right, C. Well, I'm pretty convinced that it must be C if all of you very intelligent people are saying C. And if my head wasn't in the way, you would see it is C. That is outstanding. You are all absolutely wonderful. Oh, we've got Man Like Paul, who came in with a C. We've got Sharjeev. Hi, Sharjeev. He came in with a C. Pixelator with a C. And we've got Swiftblade with a C. So you guys are all switched on. That is super brilliant. So let's go on to the next one then. What will it bring? Let's find out. How many characters does ASCII include? We're talking about character sets. We're talking about bits. Is it 256? Is it 120? Is it 4 million? Or is it 10? 10's a nice round number, isn't it? I wonder. Ooh, we've got some very quick answers here. The first quickest answer on the buzzer was Emad, who said, hang on, he's vanishing. Ah, I can't keep up. You are all going so quickly. I need to make that bigger. We've got Emad, A, Aditya, A, Hashbrown, A, Sharjeev, A. You're all Aing. Well, do you know what? Let's put you out of my misery. It is indeed 256. Outstanding. And don't forget Unicode's the other one, which has more. All right, so let's go on to the next question. Not the next question. Let's go on to the topic. What have I done? 4 minutes. I did slightly fewer of those this time because this network and topologies covers quite a lot of ground. So I'm going to try to be succinct, but there is more to go through today. So let's jump on and think about what we need to get done today. So networks and topologies, at this point, we're actually starting a new topic altogether. So we leave memory and storage behind, and we're into computers, networks, connections, and protocols. And by the way, the compression that I didn't cover last week, rather than muck up all of the settings and all of the URLs, the links for each live stream, I've put the compression one at the end, but it's quite straightforward, really. So we're doing computer networks, connections, and protocols. We're doing this over a couple of weeks, so we're going to bite off as much as we can do today, which is types of network, factors that affect network performance, client server, peer-to-peer, which people oddly always get wrong, never quite understand why, and then the hardware. Now, I've become aware that I say this about every single topic, but I cannot remember a paper where they haven't tried to make sure that you know the difference between a LAN and a WAN. I just cannot remember that ever having happened in the past. Yeah, it would only be one answer. That is a totally fair point. And of course, listen, I didn't question you, man, like Paul, with a name like that and with such a handsome face. A 25% chance it's about right. So let's whiz through these and see if we can get through this. I'm not going to stay beyond half an hour because that is the deal. And if you can't teach it properly in half an hour, you shouldn't be teaching it at all. So your 5-minute teach. What's a computer network? Obviously, it's one or more. It says two or more. Two or more computers is correct, connected to share information and resources. Now, this idea of sharing resources, there's usually, if you take that word share and then you extrapolate it and think about sharing peripherals, sharing resources, sharing an internet feed, an internet connection, you could have 3 marks right there on the benefits of using a LAN. Don't forget, this can be physical, as in connected by cables, wires, by Cat5 cables, or it could be wireless. And we need to think about the advantages and disadvantages of both of those, all right? So that's that's why we'd have a network in the first place. So let's look at the advantages. Sharing. If you keep that word in mind, you can talk about sharing files, internet connection, sharing communications. It allows user accounts to be stored centrally, and if I get my gigantic head out of the way, you can see it allows collaboration and to log in from any device. So have those remembered somehow. Use a mnemonic, use a mind palace, but make sure you've got shared. Gives you a couple of options there, but you might need 3 or 4 different ways of talking about the advantages of networking computers. Okay, so there are significant advantages of doing it, which is why organizations do network their computers. Disadvantages: there's a reliance on networked resources. So if everyone had their own individual computer, you wouldn't be relying on network resources. You'd just be using what you have on your computer, which is what we have at home often. The hardware, network hardware, is expensive. We'll talk about servers later on. Servers are pricey. Cables are expensive. Wireless connections are expensive. It all adds up to money. And if you're a small business, that will be a significant factor in deciding what you do. You increase the risk of being hacked and of viruses becoming introduced to your network when you have a network. And also, you require specialist staff. You need someone who actually knows what they're doing, and that is one of the issues that you have with network computers. You need someone who knows what they're doing. It's not just a question of plugging one computer into another. All right, let's push on. Types of network: LAN and WAN, big and small. So let's just do the detail. LAN is local area network. It is, for your 1 mark, it's a network over a small geographical area. It's usually owned by the organization that uses it. And notice you can drop down and look at WANs, large geographical area, a wide area network. An example being the internet is the biggest WAN of all. And if you think about ownership, say for example, you've got a local area network at home or a local area network at school. The school actually owns all of the infrastructure. They own the computers, they own the switches, they own the servers, they own the cabling, they own it all. Whereas a wide area network like the internet, it's not owned by one individual. It's usually rented by companies. So in the case of a WAN, a device can be owned by the telecoms company, and it's usually leased or rented out, okay? A LAN's for one site, a WAN can be for multiple sites. Again, in the early questions on this in the exam, they're going to focus on, do you know a LAN from a WAN? Do you know why networking is advantageous and what the issues with it are? All right, so you've got that done and dusted. Where are we? 1840. I'm going to move on. Right, the next chunk of this, if you can remember from that sheet up from that information I showed you at the start, is factors that affect network performance. So when you're looking at the speed of your network performance, how quickly data is being moved around, you've got various factors that can influence that. So let's whiz through those. Bandwidth. Bandwidth means the data transferred in a given time, and that's the easiest way of describing it. So, and of course, you pay for the bandwidth. So your parents or carers will pay for a certain package from Virgin or BT, which will include how fast your internet is. So it's the amount of data that's transferred in a given time. The more data that's transferred in a given time, the faster your network connections will be, and the quicker you can download files, and you're more likely to watch 4K without it juddering and generally falling over. Then you've got sharing bandwidth. If you've got to share bandwidth with other people, again at home, a good example, if you've got 3 siblings at home who are all on Netflix or YouTube at the same time, your connection will slow down because those resources are being shared across people. Then we've got this idea of transmission media. Transmission media is a fancy way of saying wireless or cables, but you've got different flavors. So let's just jump into that really quickly, okay? Your wired network is going to be quicker. Cables are faster than wireless. The problem is wireless has many advantages because you don't have to alter the fabric of the building. You can get the entire network to work by just installing more wireless network points. Whereas each time that you add new nodes to a wired connection, you've got to drill holes in walls, you've got to lay cable, you've got to move desks. It's a pain in the neck. But the other thing about wireless is that wireless doesn't necessarily work well in buildings that are metal, in buildings that have got thick walls. So there's lots to consider, which means that you might need more wireless points, which will be more expensive. I'll come up for air in a second. So that idea of wired versus wireless, wired quicker, wireless more convenient and slower. However, there are of course security issues with thinking about a wireless network because they're easier to hack. So make sure you're happy about those different transmission media. Let's then look at copper versus fiber optic cable. So copper cable is generally what we have inside our houses. It's what we use at school. Those Cat6 cables, which plug into every computer, those are the standard, and they are fast and they are cheap. Well, they're relatively inexpensive. Whereas compared to fiber optic cable, the data is sent through pulses of light. Light travels at 186,000 miles per second, so it's quick. There's nothing quicker, and it's fabulous. It's fabulously fast at sending data around the world. Problem is, it's expensive. It's the Gucci solution, but it's super pricey. So that's the advantages and disadvantages of fiber optic versus copper cable. All right. So make sure, again, that you've got some ideas around the pluses and minuses of copper versus fiber optic, the pluses and minuses of wired versus wireless, and this all feeds into the things that will affect the speed, the performance of your network. Then you've got, within the network, the hardware used. So if you've got a very modern computer, it's going to move data around more quickly because of the hardware in the computer than a laptop that's 10, 15 years old. And the way in which the topology of the network will also have an impact, but we look at that next week. So we know we've got different topologies, don't we? We've got ring and we've got bus and we've got mesh and so on. We'll talk about those next week. And then we've got error rate, the number of errors that occur, because each time an error occurs, the data has to be resent. And then we've got latency. And latency, what do you call it in gaming terms? When lag. There you go, lag. I knew it would come to me. So latency is lag. That is something else that can affect the network performance. Good. That was a lot of information there, but hopefully you have an idea now of what this topic is about and what you need to go away and look at. Where are we? 44. Peer-to-peer client server. There's a lot to get through today. So these are the two different options that you've got: peer-to-peer network and a client server network. Peer-to-peer is really easy. At home, you're more likely to have a peer-to-peer network where simply your nodes or your computers are connected together. It could be wirelessly, it could be a wired connection, or it could be both. And it's simply that they're plugged together. All devices are equal, and you can store files on individual computers and share them with others if you want to. So that's the easy one, because that's the one that we all know from experience. When you try plugging computers together, connecting them, and then you can share resources, but each device is equal. Then we've got client server. In the client server relationship, you've got two different types of computers which have both got distinctly different roles. You've got the client and you've got the server. Now, the clients are managed by the server, so you've got lots of computers that are managed by a server. A server is a powerful computer, fundamentally, and it involves the files and the software being stored centrally. So this difference between them, we're now getting into the kind of medium mark questions with these. These tend to be the more tricky questions on client server, because some students struggle with this concept. Bit more detail then, client server. Two computers, different roles, I mentioned that. The client's managed by the server. So far, so good. And that files and software are stored centrally. So that's an advantage there. So the way this works is the clients, the regular computers, send a request to the server, and the server processes those requests. Now, the server also stores user profiles and passwords. So that's your client-server relationship, which is distinct from peer-to-peer. So let's go on now and have a look at the pros and cons. This is the client server still. So it is easy to track files on a client server because the files are stored centrally, not stored locally on each computer. It is much easier to do backups in a client server model. It's also much easier to install software because you install software across all of the different nodes or computers at one go. At school, if they want to update a piece of software, they update it once, they press the send button, whichever button it is, the action button, and they just do it. It just goes, and it does it all at one go. Because in the olden days, before we had this network, they would have to go around with their Windows 95 disk and put it into each computer. So it took forever. It would take one person 2 weeks to update all the computers on the entire site. So things have changed dramatically. Managing security is far easier in a client server because you can have central management of all the security. So when we're thinking about the chances of being hacked or viruses, malware, adware, ransomware, etc., it's much easier to manage that, and it's more reliable. So there we go, which is why people use them, which is why we've got 3 servers at school. They've actually been virtualized, so we've got a print, a web, and a file server running on one server, which is information you didn't know, but it's quite interesting. All right, so the difficulties, which I've written hard for some reason, don't quite know why, is that they're expensive. They require specialists. You need to know what you're doing to set up servers like this. But also it means that you are dependent on the server. If the server goes down, you can't do anything. Well, you can do some stuff, but you can't access the files. So that would be a serious issue. There's also a danger of putting too many people on one server, which can lead to poor network quality. All right, so that's your server, client server, pros and cons, done and dusted. 12 minutes. We're going to make this because this is the last bit of teaching here. I know I've put 5-minute teach. It's such a massive lie, isn't it? Sorry, but this is the last slide now. OCR love their hardware, and that second one there that you can see, routers. So this is all about the hardware that you need to create a network, to connect a standalone computer to a LAN. You need wireless access point, routers, switches, and NICs, as well as the transmission medium, which I've talked about before. So let's start with wireless access points. Wireless access points allow users to access the network or the internet, and you need to understand that that's the purpose of a wireless access point. We've then got routers. Routers are more interesting in many ways because routers, they transmit data between networks. They also allow a LAN, a local area network, to connect to the internet, to a wide area network, and they direct data packets. So they direct data packets across the internet. So we know that data sent in packets. So if you've got a 2 gigabyte file, it'll get chopped up into small packets and it'll get sent from your LAN via a router onto the internet. But then routers between between where you are and the destination will the final destination will actually route the package according to the quickest route. So these packages will go on different routes and they might arrive at the destination out of sync, which is why they're all numbered, by the way. So packet 1 of 10, 2 of 10, 3 of 10, and they're all put back together like a big jigsaw, and that's how it works. So that routers actually have a really important job. OCR are quite obsessed with routers, and I'm not sure they could go a whole exam without asking a question on it. So make sure you're happy with what routers do. Switches, in comparison, are quite easy. They just connect devices on a local area network, and they transmit data between nodes. They transmit their data to the MAC address, MAC, and the MAC address on a computer or on a node is a hard-wired address. So the MAC addresses are used on a LAN. The IP addresses are used on the internet, on the WAN. I know I'm throwing a lot at you here, sorry. And then we've got NIC, the network interface card, and that allows a device to connect to the internet. So for example, without a network interface card, your computer couldn't connect to the internet. So it is that card that allows it to happen. They're quite often built into the motherboard these days, and that's where you'd plug your Cat5 cable or Cat6 cable now into the back. Or there's also a wireless network interface card, and computers these days have both a wired and a wireless network interface card. Transmission media, Gucci, fiber optic, cheap and cheerful, copper. Okay, so that is that. It wasn't a 5-minute teach, but we have covered quite a lot of ground. We're now into quiz time, 9 minutes left. I'm going to finish on time. Which of these is a characteristic of a LAN? A, B, or C? Covers a wide geographical area, data transmitted at a slow rate. It covers a small geographical area. What do we think, ladies and gentlemen? I await your answers with interest. Who is here? We have Emad, who is coming with C. Can I get to his name before it vanishes? No, we've got Aditya with C. We've got Pixelated with C. We've got Hash Brown with C. We've got Bogdan with C. We've got Man Like Paul with C. We've got Sergen with C. We've got Swift Blade with C. You are all geniuses, or genii, I think is the right way of saying that. Indeed. So LAN is a... We've got Flynn as well with C. LAN, it is a... My head... I need to move this so my head isn't directly in the way. There you go. So that is outstanding. I think you deserve a bicycle horn for that effort, which I'm sure has cheered you all up no end. Right, so that is the first one. Let's go on to question 2. Which of these is a characteristic of a WAN? Dead easy. If you get the first one right, you get the second one right. These are sort of grade 3 questions, grade 4 questions. So this is the stuff that you need to mop up really early on in this sort of networks topic. Oh, hello, they're coming in. We've got Bogdan was the first with an A. We've got Aditya who came in with an A. I've got Hashbound Gaming with an A. I've got Pixelated with an A. I've got Emad with an A. I've got Swift Blade with an A. I've got Sergen with an A. I've got Conso Bonso. Hi, Conso Bonso. And I've got Emily May. Hi, Emily May with an A. I've got Swift Blade with an A. Yeah, I mean, you're all geniuses. What can I say? It is a Man Like Paul with A. I'm not going to ignore you. You're clearly my favourite. So, wide geographical area. All right, LAN versus WAN. That's the easy stuff, isn't it? All right, so let's go on to question 3. Which of these statements is true? This is slightly nastier. Each computer on a client-server network is maintained separately. Well, you can read for yourself. I won't do it for you. What is the answer? What do we think? A lot of information. And I know that wasn't your answer, by the way. So we have got, Swiftblade's come in with a B. So's Bogdan. So has Aditya. So has Emad. So has... Look, your Armani jacket was very nice. I was only jealous. I'm a teacher. I can't afford Armani. So I take it all back. Any abuse I directed towards your jacket was purely intentional. Unintentional, purely unintentional. I've got Sergen with a B. I've got, it was a nice jacket, okay? I've got Conso Bonso with a B. I've got Emily May with a B. I've got Flynn with a B. It was a nice jacket. I'm being nice. Come on, you know how painful I find that. So the answer is B. client network server, central computer that provides services to the rest of the network. That's a good definition there of what it does. Okay. Thankfully, I don't know what that means. If it's something rude, good for you. Right, let's get on. Next one. Boop. Question 4. And I'm going to finish on time here. Where are you most likely to find a peer-to-peer network? In a large office, at home, or in a large organization? Which annoyingly is spelt with a Z, which is not something that I agree with, frankly. At home. Oh, we've got at home. That was Aditya at home. We've got Bogdan at home. We've got Flynn at home. I can't keep up with it. Oh, there we go. We've got Pixelated B. We've got Sergen B. We've got Emad B. We've got Hash Brown Gaming B. We've got Emily May B. We've got Swiftblade B. Shall we see if you're all correct? You know you are. We've got Man Like Paul with a C, who's just giving me answers now because I was mean about his jacket. It's a nice jacket, okay? I just can't wear white because I spilled ketchup on it. So that's good. Yeah, outstanding. Very, very good indeed. A, B, and C. Well, do you know what? You've got everything covered there. So, have I got more questions? I can't remember. I do. So this is a question based on the on the one that I didn't do last week. So I'm sure you'll do very well in this. But people of your intellect and those of you who work so hard, which of these are not usually in a compressed format? Do we know? A, B, and C. You're sticking with that. Swiftblade said C, not usually compressed. A, B, and C. Okay. We've got C. We've got A, B, C, and D. Should have added E just in case. We've got MPEG. 25% chance. This is so true. So based on what I didn't teach you, do you know, someone eventually, I knew that from the law of averages said someone would get it right, and it is Aditya. He's changed his mind now. Okay, so actually, the answer is bitmap. All the rest are compressed. JPEG, which stands for Joint Photographic Experts Group, is a compressed image. MP4 is a compressed video file, and MPEG is also a compressed video file. MPEG is not as compressed as MP4. AVI is the uncompressed video, which is gigantically big. All right, so it is actually B. So no applause, because the one person who got it right then changed their mind. So we have question 6, 3 minutes to go. Which of these is the correct definition of a router? They love a router, OCR. Type of transmission media that provides the greatest bandwidth, server with a network, forwards data packets on a network, corrects errors that are found in data packets. Ooh, Aditya came in quickly with A. Swiftblade came in with A type of transmission media. Ooh, Flynn's come in with C. And when I say and I say, yes, Bogdan, you too, that is the correct answer. What's really interesting, well done, Hash Brown, that is outstanding. Emmet, that's good. Pixelated, that is good too. It is C. For some reason, even though we use routers all the time, we don't often know what they do. I think the reason is because you've got one box that does everything. So a router will allow your network at home to connect to the internet, but it's also, routers have got a really important job on the internet, yes, within the internet to forward data packets. So there we are. Hedging your bets there. All right, so then where are we? 2 minutes to go. I'm going to finish on time. Oh, there is one more. Which of these refers to the maximum rate at which data can be transferred? So come on, guys, let's whiz through this really, really quickly, please. Which of these refers to the maximum rate at which data can be transferred? What do we think? A, B, C, or D? Oop, I can see. Oh, it comes through here faster than it comes through on this screen. So hang on, I've got Bogdan with A, which I can't keep up with. I've got Aditya with A. I've got Swift with A. I've got Pixelated with A. Hash Brown A. Sergen A. You guys are right. It is A. That is outstanding. So well done. Let's give you a ding and an air horn, some boxing gloves, and a party noise maker, because that's what you deserve. I think I'm running out of time, and I've got to this slide. Woohoo! We covered a lot today. Revision ideas, obvious really. The stuff we've done today, make some notes on it. Make sure that you've made some notes that you can revise from. Plan your definitions for different networks. Do you know LAN versus WAN? Routers, NICs, switches, they come up a lot. characteristics, pros and cons of various media. So wired versus wireless, and copper versus fiber optic. Okay. Be confident in your definitions of peer-to-peer versus client-server. Now, I'll ask you a different question on registers next time. Make sure you know it and use that planner that I gave you to get your revision done. And then next week, we are going to look at this lot here. DNS, hosting the cloud, web servers and clients. It's 7 o'clock and I finished on time. That was marvelous. Guys, have a lovely evening. I hope that's useful. I'll put this on YouTube. Any questions, let me know and I'll give you the PDF as well. Guys, have a lovely evening. It's been a pleasure. I will see you all same time next week. So that is goodbye to Swiftblade and goodbye to all of you. See you guys. Take care. Bye-bye. Take care. Bye-bye.